So a map of the zombie apocalypse. It seems kind of far-fetched, and it is, to be honest with you. The theory behind it is solid, though. Mapping a disease is useful in a lot of ways. The CDC uses it to track the flu virus each year, cold, Ebola, so all the stuff you see in the news. They do this kind of stuff, maybe not this exact model that I'm going to be showing you, but they use that to demonstrate how far it can penetrate a population. I did a lot of this work with Gavin Buxton. He was really instrumental in kind of showing me how the models all work, because it was very new science to me. So, spread of disease is important. We already discussed that. The populations that I used in my model were the normal population, the infected population, the zombie population. I monitored all of those going through. Although the two that we're interested in the most are the infected and zombie. I based them on George Romero's zombies. I chose to do this because he created a lot of films over a long period of time. So a longitudinal study, essentially. He started in 1968 with his first Night of the Living Dead film, and he filmed 3 in that series, and then continued filming more zombie movies up until 2007. So quite a span of time there, and his zombies remained the same in all of the films. So that's why I held constant over time. The zombies didn't run. They gave the disease to people through scratches or like in exchange of fluids, so blood or saliva, something like that. And when regular people died in his films, they became zombies after. So I used all of those in consideration when making my model. So the hypothesis for my model was that if the model correctly displays, if I accurately portrayed it, the infected and zombie populations will spread to all parts of the U.S. within a 24-hour time frame. Because most of the movies follow a time frame of like one day it happened and then the next day everybody was like gone. There was zombies everywhere and the population was so low that it didn't matter. The software I used was LibreOffice. It's a spreadsheet kind of like Excel. I used an SIR model and a diffusion model. I'm going to go over the spreadsheet layout and the formula I used in this software. This is actually the map that I had generated of the U.S. I used the population densities and the total square mileages of each state, and created this map trying to represent each state equally. Each block ended up being about 800 square miles, and that was just how it happened to work out. So I tried to keep it as constant as I could through each. I took the population, I took the square mileage, divided it by the blocks, and then multiplied by took the population into account and divided it into each block. So it was consistent throughout each state. The SIR model is a basic model, or a skeleton model, not really a basic model, so it can get really complex. It goes from susceptible to infected, or someone who's susceptible can remain susceptible. Infected is actually the most interesting. You can revert to susceptible. So a mutation of a new strain, or a mutation of a new strain comes out, and you can go back to being susceptible to the new strain. If you're infected and you become removed, you can either become immune or you could die from it, or pass through your system. And the removed could go back to susceptible once again by a new strain coming out and then being susceptible again. My model took normal humans and they were allowed to stay normal, become infected, or die because it was within a 24-hour time frame. So I did take into account antidote being developed in 24 hours of it breaking out. So the infected could only travel to zombie, and once you were dead, you became a zombie. So the diffusion model just takes the chance that in this cell you travel to the cell beside you, on either side, above or below you. So as you can see in the picture up top, the original location has 4 places it can go. Once it spreads to one of those locations, it has an additional 3 that it can transport from, and that's how it just kind of spreads throughout without including any airports. So this is how I laid out my spreadsheet. I had all of my populations on the left, my initials. I had a formula that I calculated the new updated population to the right of it. I copied those populations to the right so I could use them as my new initial. So I could use time as my variable. Just do a timestamp so it would keep changing. That makes sense. So with the normal people, I didn't really take into account flying on planes because it didn't matter because the population was static for the 12 hours. The infected used the airports because they weren't quite zombies yet. They weren't like showing any symptoms at the time. So they were still allowed to travel. Zombies were not allowed to use the airports because nobody's going to let a zombie on a plane. And so I took the diffusion of the zombies and the diffusion of the infected where they currently lie and mapped it, spreading out from there. So here's all the formula I used. I'm going to give you the Cliff Notes version because it's a little boring. All of you know what delta T is. I already explained the diffusion. That's just the way it gets written out. So it balances, you multiply the center block by 4. The calculation for N, I just took the birth rate for that time. I included that factor by the normal population. The infected becoming infected, or the infected giving their infection to a normal human. The infected being infected by a zombie is the beta N Z. And then death of normal people, and followed by the zombie-induced deaths for N. I use kind of the same variables, so beta means the same. IZ means that the infected zombie turned into a zombie, or the infected person turned into a zombie, rather. And the gamma stands for the chance that you become infected by an already infected person, not necessarily the zombie at the time. The infected using the airport was a little bit tricky. I had to develop a grid, which on the previous spreadsheet layout, in the top right corner there was a map of all the airports with how many people were in the airports. And I used the change in time and the location. The change in time and the location to directly correlate to the amount of infected that were also in that location times the probability that the amount of people leaving that location over the total amount of people leaving every location in the US. So that's how I figured out if a zombie was on the plane, in essence, or if the infected was on the plane, rather. Calculation for zombies. We've gone over all these variables. I think the only new one at the bottom is the D sub Z, and that's the zombie-induced deaths of humans, which would also result in zombie. So I mapped the progression. First is 6 hours, second is 12 hours. Just the zombie population. As you can see on the side, the yellow and the pink are kind of more prevalent at 12 hours. Through the next, 18 and 24. There aren't a lot of zombies everywhere, but it definitely did spread. I started in Atlanta, so it was a major hub, and it spread out throughout the United States. That way, the infected did, and zombies came about through that. In order for the zombies to be even as small as they are, even as little areas they covered, the infected took over a lot of the United States, even in the first 12 hours. As you can see, in 12 hours, there was more than 1,000 people per block in Florida and New York City, Newark, highly densely populated areas, Connecticut, places like that. And this is hit at 24. Didn't quite travel the whole way throughout the United States and missed one state. So, in summary, the zombies didn't really travel far, although the infected traveled a lot farther because they were able to utilize the air transport. I think if given more time, they would eventually travel and take over the last state, but in the end, my hypothesis was proven to be false because there was one state that didn't get any infected or zombies in it. Air travel expanded the reach of the virus. If you think about the map that showed it started in the southeast part of the country, and it traveled the whole way up to Washington State, and there was even a dense population in Wyoming. There was over 1,000 per block in Wyoming, which is still like a pretty sparse state, like not very densely populated. So some of the limitations were the population was static. I used old census data, and my specific zombie attributes were different than maybe other zombie attributes you might want to take into consideration. My maps also not perfect. I did put a lot of time into it, so I think it's like kind of close, but I'm willing to accept that it's a little wrong. Possibilities for future research are mapping patterns of other diseases using the model that I've created, adding more routes such as bus routes, train routes, daily commutes between cities, stuff like that. If there's any questions, they're actually able to have questions.
Everyone of the panelists want to come